Hi everyone, this is Mrs. Fagan, and in today's goal, what we're trying to do is solve quadratic equations using completing the square method. Alright, let's go ahead and kind of talk about what we have been doing so far and how this fits into the entire unit. So we started this chapter with solving by graphing. So there are different methods of solving a quadratic, and the first one we did was by graphing. And basically what we did is either using our calculator or by hand, we started graphing these, and we ended up getting a parabola shape. Came from the quadratic equation. And then what we said was these were called the zeros, and then we ended up being getting numbers like x equals 2 and x equals -3, if that's where it was, 2 and -3, and those were our solutions. And so that's one way to solve a quadratic, was to figure out where it touched the x-axis. From there we went into a second method, and the second method was by factoring. So we solved using factoring, and we factored quadratics into factors such as x minus 7 and x plus 6 equals 0. And then we set each factor equal to 0, and we solve for each x value. So x in this case equals 7, and subtract 6, x equals -6. So those were our solutions using the factoring method. From there, we went on to a different method, and that was solving using square roots, where we would have equations such as x squared minus 3 equals 0, and we couldn't factor it, so we would add the 3 to the other side and take the square root on both sides, getting ourselves a plus and a minus square root of 3 for our answers. So our solutions ended up being square root of 3 as well as negative square root of 3. Alright, well today what we're going to talk about is solving using the completing the square method. So this is the fourth method that we are going into, and it's called complete the square. And so that's what we're going to learn today, and you'll kind of see how it plays into this entire quadratic unit. Okay, it's just another method that we're going to be looking into. Alright, let's go into the question of what is completing the square. Change my color really quick. Alright, so this is a process that allows you write an expression of the form x squared plus bx as a square binomial. We'll say of a binomial. Okay, you're going to see what that means in a second. So let's kind of start with the following problem. Okay, so it says, example 1, solve the quadratic x squared plus 10x minus 3 equals 0 using completing the square. Alright, so there are several steps that we have to take. First thing we have to do is get the x squared and the x term by itself. So I'm going to move everything else I don't need to the other side of the equal sign. So I'm going to just rewrite the problem again. And I'm going to go ahead and add 3 to the other side because I don't want it. I just want the x squared term and the x term to be on one side. And then this is now 0 equals 3. Now, I did leave a blank there because I'm going to actually need some space there. So I'm going to add a plus blank and a plus blank. What we're going to do is come up with a number that's going to make this a perfect square binomial. I'm sorry, not a perfect, but just a square binomial. And you can start the process when you have a couple things. First, the leading coefficient on the x squared is 1. And 2, when you only have the x squared and the x term on one side and everything else on the other side. Notice that I added a plus blank here and a plus blank on the other side. The reason for that is because whatever we do on one side of the equation, we have to do on the other side to keep a balance. The way we find what this magic number is by taking the b value. And in this case, the b value is 10. We take the b value, 10, and what we do is we divide it by 2 and we square it. So we're going to go ahead and divide by 2, and we're going to go ahead and square it. The number that we are going to have, which is going to be known as the c value, is now going to be 5 squared, and 5 squared is 25. This will equal c. C values are the blanks that we just put here. So if I'm adding 25 on one side, I'm going to go ahead and add 25 on the other side. Now, if you're going, what just happened? Be patient with me as we do more of these problems. It'll start to kind of make sense. Alright, now we're going to go ahead and factor this. We know x squared is x and x. And two numbers that multiply to 25 and add to 10 are 5 and 5. They have to be the same number. As a matter of fact, these factors have to be the same. They're both going to be positive because everything is positive. And if these factors are not the same, that means I made a mistake somewhere. 3 plus 25 is 28. And here's what it looks like. X plus 5 squared equals 28. Once we get it into this format, now it is just like using the square root method. Okay? The whole idea of getting completing the square is to get it so that we can actually figure out what the x values are. Alright, so right now this is where I'll actually write it here. This part right here is a square of a binomial. So once you get that, you know you've completed the square correctly. Alright, now what we do is do what we learned in the square root method. We're going to go ahead and take the square root on both sides. We get x plus 5, because square and square root cancel, equals plus or minus square root of 28, which we'll simplify in a minute. And then we have, actually let's do it now. X plus 5 equals plus or minus. Now, this inside of here is, I know, 2 times 14. I can break down that more. 2 times 7, so 4 times 7. Therefore, I can take out a 2 out, so that's 2 square root of 7. Alright, I'm going to go ahead and subtract the 5 to the other side. We squeeze it in right there, subtract 5. So x equals, this cancels, negative 5 first, plus or minus 2 square root of 7. And that's our final answer. We have solved the problem using what we like to call is the completing the square method. Great job. Alright, let's go into the second problem. So second problem is going to be very much the same. We're going to go ahead and solve using completing the square method. So we're going to run through the process one more time. So first thing we need is the x squared and the x term by itself. So we're going to move that 5 to the other side. So I'm going to just rewrite the problem here because it does take a lot of space. So I like to just start it from the left side. Alright, we're going to subtract 5 on both sides. Here we go. So we are left with x squared minus 12x. I'll leave a blank there where the 5 used to be, equals negative 5. Now, I'm going to check to see if I can complete the square. Well, let's see. We have a 1, leading coefficient of 1 for the x squared term, which is what we want. And we have the x squared and the x term by itself. So let's go ahead and add the plus blank, which means we could do add the plus blank here too. Alright, so now we're going to go ahead and find our c value. Okay, so remember that c equals b divided by 2 squared. And remember that this one is the a term, which we don't really use. This one is the b term, and this one is our c term. Alright, let's go ahead and get started. C equals, b is negative 12. We do have to take the negative with us, divided by 2, and square it. C equals negative 12 divided by 2 is negative 6. Squared is going to be 36. So our C value will be 36, and we're going to go ahead and add that to the other side as well to keep everything balanced. Alright, now we're going to go ahead and factor this. X and X. Two numbers that multiply to 36 and add to negative 12 are negative 6 and negative 6. Now, if you're going, how is she doing this so fast? Here's my little cheat sheet. Do you see that negative 6 inside the parentheses? That's where I'm getting it from, actually. Equals 31. Alright, so now we can write this as x minus 6 quantity squared equals 31, and we go into the solving of this. We're going to go ahead and square root both sides. Square and the square root cancel. We're left with x minus 6 equals plus or minus square root of 31. Now, I don't think we could simplify square root of 31 any more than that, so we're going to just go ahead. I'm going to rewrite this here one more time. And then last thing we got to do is add 6. And remember, we have to squeeze it in front of the plus or minus. X equals 6 plus or minus square root of 31. And that is our final answer. All right, well done. Now, there's a different type of a worry that we might have as we're doing these completing the squares. And I'm going to kind of show you that in example number 3. Nothing to worry about. It's a very small adjustment. All right, look at example number 3. So in example number 3, we have several things happening. First, we have the 3 on the other side. So I'm going to just rewrite this again here. We're going to go ahead and move the 3 by subtracting 3 on both sides. We're left with 2x squared minus 12x. I'm going to leave a blank there, minus 3. Now, we can't really start the process until this is a leading coefficient of 1. So what we're going to do is use our factoring skills, and I hope you can see why we had to teach you certain things before we can even get to completing the square. We're going to go ahead and factor out a 2, and I'm literally going to put it on the outside. So I'm going to factor out a 2, and what we're left with is x squared minus 6x with a space equals negative 3. Now, at this point, we do have a leading coefficient of 1 here in front of the x squared, and the x squared and the 2x are there by themselves. So we're going to go ahead and start the completing the square process. This 2 is going to play a role in just a second, so bear with me. Plus blank plus blank. Now, technically, the blank that I add here has to be multiplied by the 2, because if you were to distribute this in, it would be 2 times the blank that we have here, the green line. Because of that, we must actually multiply this one by 2 times blank as well. So just to keep it balanced, do you notice that? Let's do that one more time. I just want to show you. So 2 times blank, 2 times blank. Therefore, it's pretty fair. All right. Everything else is the same. We're going to go ahead and find the c value by taking the b, dividing it by 2, and squaring it. In this case, b is negative 6. c equals negative 6 divided by 2 squared. c equals negative 3 squared. c equals 9. All right. So now we have 9 in the blank spaces, and notice it's 2 times 9, 2 times 9. That'll kind of balance itself out, and we continue the process. We don't ignore the 2 because the 2 is still there, and we're going to go ahead and factor out what we have. X and x, 2 numbers that multiply to 9 and add to negative 6 are negative 3 and negative 3. Notice they're always the same factor. Equals, we have negative 3 plus 18. And we continue. We have 2 times x minus 3 quantity squared equals 15. We're going to go ahead and divide by 2 first before we do anything. And we are left with, I'm going to move it to the side, x minus 3 quantity squared equals 15 halves.
And then you need to take the square root, right, Mrs. Began? I'm going to finish this one because this is my favorite type of problem, because it's so important to know that from here the only thing you can do is take the square root. That's the only way to get rid of this exponent. So sometimes people want to do something else because of these parentheses, but we don't. And then, since you have a fraction here, that's really like saying the square root of 15 over the square root of 2. And make sure you include your plus or minus, right? Anytime you physically write down your square root, you need to have your plus or minus right away. And then I need to rationalize this because I'm not allowed to have that radical on the bottom. So I'm going to multiply top and bottom by square root 2. So I have x minus 3 equals plus or minus the square root of 15 times 2 is 30 over 2. And we can't simplify that anymore. So I'm going to add 3 to both sides. And remember that 3 goes right in there. So x equals 3 plus or minus square root of 30 over 2. And we can leave it just as one answer, because with the radical, we're not going to be allowed to combine that with the 3. All right, back to you, Mrs. Pagan.
I want you to go ahead and give example number 4 a try. This is a problem that we're going to go over in class together. Okay, so please do not forget to try it. I think it's really important that you try it without us. And if you want, you can even draw a line so it's your attempt, and then we'll kind of do one together in class as well. Can't wait to see you. Great job today. Have a wonderful day.